Lester, Wushu engineer. Today what I'd like to talk about a little bit, and we're going to do an experiment to determine this, is really a bit of a response to a video posted up by Matt from Scholagladiatoria, whose channel I really quite enjoy watching. He's got really good content on his channel, well researched, and he knows his stuff. And I'll put some links in the description below to the particular video that I'd like to respond to, and also to his channel, so that you can check out some of his other stuff. Really excellent resource, especially for those who are into historical European martial arts, and really any martial art, really. The video in particular that I'd like to respond to is a video in which he was discussing just a really fun topic, which is Warhammer 40,000 and the gaming system. Not really the gaming system, but applying his knowledge of historical European martial arts and basically fighting in general to some of the weapons and armor and technology that's available in the Warhammer 40,000 universe for essentially for duking it out between various sides, whether it's orcs or humans or Eldar or elves, etc., etc. Now, during his discussion, he mentioned a technology which is part of another sort of genre and universe, which is the Star Wars universe, and this technology is the Vibro Blades, known as the Vibro Blade. You'll find that it's a commonly occurring science fiction theme, actually, in a number of different universes or stories, in which a melee weapon, quite often a blade or a sword, is treated in such a way, or it has certain electronics or mechanical features that cause the blade to vibrate, so that and the idea is that when the blade strikes an object or a person, it does more damage in some way. And Matt's comment was that because of the way swords in particular or blades are used, as they're being used at the point where they're being applied to an enemy, that point of contact, or the instant of that contact, is so small that having a blade that vibrates isn't going to do anything. Well, so I thought I would investigate it practically, just as a sort of a precursor to investigating it in more detail, perhaps, when I have funds available. So what I've done is I've set up a little test to test how long that point of contact might be for a weapon striking an opponent. And so without really very much further ado, we'll actually just go straight into the testing part, and then we'll discuss it afterwards. As you can no doubt tell, I'll look different in the rest of the video. The rest of it was shot at an earlier date. I haven't actually had an opportunity to shoot the introduction, so I kind of know what's going to happen. And so I won't spoil it for you, but what I will say is that what I intend is that this video is perhaps just to whet your appetite for potentially looking at the practicality of building a power weapon like a Vibro Blade, and testing it to see exactly what it would do and whether it would be of any use at all. And that, of course, is a whole nother question that needs to be answered. Whether it's possible, I would, as you'll tell from the rest of the video, I think that it may actually be possible to build something like a Vibro Blade. What it would do to a target is, as I said, another question that would really have to wait on practical examination and experimentation. So I hope you enjoy the rest of the video. So I'm going to explain the equipment and the methodology, and I'm going to do the testing all in one section because there's not a lot that needs to happen here. This is a very simple setup. I had a piece of titanium offcut lying around, so I've just attached a electrical cable to that, and I've got a piece of square steel tubing which I've just taped onto the side of this pillar. It also has an electrical cable connected to it, and both of those cables are going back to the high precision timer, and I'm using the maintained run stop input. So the instant that I make electrical contact between these two conductors, it will start timing, and the instant that that contact is broken, it will stop the timer. So I'm going to be able to get I'm going to do a few tests. I'm not really looking for any kind of power. Basically, I'm just looking for a little bit of speed and what a typical strike duration would be, so that we have something to work with to find out how much time the weapon would be in contact with an opponent during a strike. And obviously this could vary immensely based on what you are trying to do with the weapon, but we're just looking for some very typical values so that we can do some basic calculations to find out what frequency this weapon would have to be vibrating at to actually do any kind of or provide any kind of additional benefit to the strike. So I'm just going to go straight into the testing. You can't see the timer because I have it set up right next to the camera, but I'll call out the times as I do the test. So I'm just going to do 10 strikes. Okay. So that is 0.0008. I'm going to go again. That's again 0.0008 seconds. So this is obviously all in seconds. And that one was slightly longer. That's 0.0014 seconds. That's also slightly longer, 0.0019 seconds. That's 0.0009 seconds. Oh, the timer switched off. We'll have to try that again. Just let me switch it back on again and reset. We'll do a few more just to get a broad range of values, and then we'll take the average. That's 0.0007, 0.0008. Well, that's the fastest so far. That's 0.0001. 0.0008, that seems to be a pretty typical number for the strike. 0.0003, 0.0007. And thus the experimental apparatus starts falling apart. But I think we have enough values now to actually get a fairly typical basic idea of what a typical strike would be. And I think just based on the numbers that we've seen, I'd say that it's probably fairly safe to say that 0.0008 seconds is a fairly typical duration of time that the weapon will be in contact with an opponent. And then I'll take that to the results and conclusion section, and we'll do a few calculations and see what we come up with. So I went through the exercise of calculating what the actual average strike duration was over the 11 strikes that we did, and it did indeed come to around 0.0008 seconds. But before I start discussing the results, I wanted to just sort of indicate where I'm going with this in terms of what this information could be used to ascertain, just as a casual examination of the topic of power weapons. Are they practical? Can we build them?
Are they practical? We don't really know just yet. Probably needs a little bit more investigation. Can we build them? I think we can. And I think the power weapon that we can immediately start developing is the Vibro Blade. So please, no funny associations. So we have basically the setup would be a short bladed weapon with a blade connected to some form of vibrating element, which will have to vibrate at a particular frequency, which we'll extrapolate from the figures that we got for the tests that we did. If the blade is oscillating back and forth along the length of the blade, essentially it becomes like a bread knife. Except without two reciprocating elements, it's just got the one. So essentially, it's like it would potentially, if it had a serrated edge, I should say a serrated edge that's in keeping with the frequency of its vibration. Of course, you'd have to really calculate what those serrations, what kind of spacing those serrations would have to have in order to best make use of the frequency of the back and forth oscillation. But if you did all of that work, I think you might be able to develop a blade that could perhaps cut better than a blade that was just being drawn across some kind of an object. By adding this backwards and forwards oscillation to the blade. So what frequency would that oscillation have to be at in order for it to be practical as a science fiction weapon? And I'll draw your attention back to the results. If the average strike duration, so that's the duration that the weapon is actually in contact with the object, is 0.0008 seconds, then we can say that based on that the period of the oscillation, which of course is the time from one peak to another peak, or one trough to another trough, would have to be also be 0.0008 seconds in order for there to be at least one oscillation in that instant of contact. So that would mean that the minimum frequency that we would have to have working through this blade oscillation would have to be, as a minimum, 1.25 kilohertz, which is completely achievable, really. But of course, why would you want to stop at 1.25 kilohertz? Because that would really only give you one oscillation in that point of contact, which might give you some advantage. But why not go for a higher frequency? So let's imagine for an instance that the frequency was 1 megahertz, which of course again is entirely achievable. That would mean that the period of the oscillation is 1 by 10 to the minus 6 seconds. For that 0.0008 seconds of contact, the blade would actually oscillate 800 times in one strike. So if you can imagine just that rapid point of contact there, at that instant of contact, or what we perceive as an instant, that blade would have been drawn backwards and forwards on that point of contact 800 times. And of course, depending on the amplitude of that oscillation, and how the blade is constructed, I spoke earlier about serrations, that kind of thing, it could actually have some kind of real-world effect on what would actually happen. So the effect of that strike. And for that matter, if the weapon was used in a stabbing motion, the tip of the weapon would also be oscillating backwards and forwards at that frequency. So at that instant of contact for a thrust, it might also be essentially like a miniature jackhammer, striking backwards and forwards against its target 800 times in one point of contact. So I think there are a number of other things that need to be investigated first. Things like amplitude of the vibration, the the amount of energy or force that can be transmitted in that oscillation, and how the blade would be constructed, and how you would power it, and whether it would even work at all. Of course, I'm an engineer, so I'm a lot more practical. I like to kind of get my hands dirty, almost prematurely, you could say, and start building things right away. But based on these preliminary calculations, I would say that it is quite possible that that the Star Wars concept of a Vibro Blade might actually be feasible based on our currently available technology. So perhaps in future videos, maybe you might see we might see the construction of a Vibro Blade, and let's see if it actually has any kind of real-world effect, and whether it would be of any kind of benefit in a science fiction or fantasy setting to have a weapon that oscillates at a particular frequency when striking an opponent. Well, that's the end of this video. I hope you enjoyed it. It's really just, you could say, I'm just setting up for potentially for future videos where we look at actually constructing some of these power weapons. And don't ask for the lightsaber, because it's not possible. And yeah, it's arguable whether if you had access to the kind of technology that could store that amount of energy and actually convey that amount of energy in such a short space of time, whether you would be using it to build swords with, or whether you'd be, doing other things with it, that would be a far better use of that technology. All right, I'll see you next time.